Welcome dear students to a very exciting lecture in which there will be a lot of learning for you people as we are going to discuss the IUPAC names of both alkenes and alkynes in this lecture. So let's start the lecture. There are different rules that we have to follow while giving the IUPAC names to alkenes and alkynes. The first one is the selection of the parent chain, which is also called as the main chain or skeleton chain. And this one is basically the stem of the alkene or alkyne, and to this stem there will be different branches that will be attached and they will be called as the substituent. So parent chain is basically the stem of the structure of the organic compound to which various branches as substituents they are attached. My dear students, in case of alkenes and alkynes, the parent chain will be one which will be having all carbon-carbon double bonds and carbon-carbon triple bonds in it. And if there will be two chains competing for the parent chain carrying all carbon-carbon double and triple bonds, then we will be selecting the chain which will be having maximum number of carbon atoms and maximum number of substituents attached to it as the parent chain. So parent chain is the longest continuous chain of the carbon atoms in which all carbon-carbon double bonds in case of alkenes and all carbon-carbon triple bond in case of alkynes are present. And if there are more than one chains that are competing for the parent chain, then the one is selected which is having maximum number of carbon atoms and maximum number of substituents attached to it. While selecting the parent chain, you will have to be very careful because this is the first step of the naming, and if you will select the wrong parent chain, the complete name that will get wrong, because the first step is the selection of the parent chain. If it gets wrong, the complete naming gets wrong. So observe the alkene or alkyne very carefully while selecting the parent chain. The second one is the numbering of parent chain. You will allot numbers to the carbon atoms which are the part of the parent chain beginning from the end where the double bond or triple bond is nearer. And if the functional groups are at equal distance from both ends of the chain, then you will select the numbering from the side where the substituent is nearer. So the first preference goes to functional group. You will start numbering from the end where the functional group double bond or triple bond is nearer, and if the functional group from both sides of the chain they are at equal distance, then you will see for the substituent and you will start numbering from that end of the chain where the substituent is nearer. And if the substituents are also at equal distance, then it's up to you. You can start the numbering from either side of the chain. Then, my dear students, the third will be naming the alkene or alkyne. While naming the alkene or alkyne, first of all, you will write down the substituents. And while naming the substituent, first of all, mention the location of the substituent by writing down the number of the carbon atom to which the substituent is attached. If there are different substituents, then you will follow the alphabetic order. And if the same substituent is repeated in the alkene or alkyne, then IUPAC recommends the prefixes 2 for di, 3 tri, 4 tetra, and like this. And then after naming the substituents, you will mention the position of the carbon-carbon double bond or carbon-carbon triple bond by using the number of the first carbon atom of the double or triple bond as the prefix. And then after that, you will give parent name to that alkene which will end at -ene, and in case of alkyne, the parent name will end at -yne, means alkyne. And this parent name is derived from the parent chain because the number of carbon atoms in the parent chain, they decide the parent name of the alkene or alkyne. If there are 6 carbons, that will be hexene or hexyne. If there are 7 carbons, heptene. In case of alkyne, that will be heptyne, and like this. So following these steps, following these rules, you can name any alkene or alkyne in front of you. Now let us discuss some examples that how we can name the alkenes and alkynes by the IUPAC system. This one is the first example, and it is very, very, very important because in this example there is the mystery of the selection of the parent chain. My dear students, when you are going to select the parent chain, first of all, always consider the straight chain as the parent chain, whether it can be or it cannot be a parent chain. Starting from the straight chain, it has 1, 2, 3, 4, 5, 6 carbon. It has 6 carbons and double bond will also be part of it. And now there is another possibility starting from here 1, 2, 3, 4, 5, 6, 7. Now this parent chain has 7 carbon atoms in it. But my dear students, if you will select this one as the parent chain, then the double bond will not be the part of the main chain. So the chain having even greater number of carbon atoms cannot be selected as a parent chain if the double bond gets out of the chain. If you will select this as the parent chain, that will be the wrong selection. It means that this chain has greater number of carbon atoms, but still it cannot be selected as the parent chain because the double bond will be outside the chain. And the parent chain is the one which has all the functional groups in it. So in this case, you will select either the straight chain or there is another option 1, 2, 3, 4, 5, 6. So both of these, they are correct. Let us select this as the parent chain. So this one is the parent chain with double bond and 6 carbon atoms. Now my dear students, in this case, again that is very simple. The straight chain should be the parent chain, or even you can go like this for the selection of the parent chain. Both will be correct. In this example, 1, 2, 3, 4, 5. The straight chain has 5 carbon atoms. 1, 2, 3, 4, 5, 6. My dear students, this continuous chain has 6 carbon atoms. But again, you will not be able to select this one as it is not having that double bond in it. So again, the parent chain should be the straight chain one. Similarly, this is our diene in which 2 double bonds are there. Again, the parent chain will be the straight chain. In case of this alkyne, you can see that the parent chain is straight chain, or there is another option, you can select this one as your parent chain. This one is a diene in which there are 2 carbon-carbon triple bonds. The parent chain will be the straight chain. Similarly, these two are the examples that we will separately discuss. These are not the part of the alkenes or alkynes. Now, my dear students, we have selected the parent chain in all these given examples. After selection of the parent chain, now we are required to give numbers to the carbons in the parent chain starting from the end nearer to the double or triple bond. So, in this case, 1, 2, from this end, the double bond is between second and third carbon. But if you will start from this end, the double bond will be 1, 2, 3, between fourth and fifth carbon. So the double bond is nearer to this end, and we will start numbering from this end of the chain. 1, 2, 3, 4, 5, and 6. Similarly, in this case, both double bonds are at equal distance. You can start numbering from any side. It will be having 4 carbons. In this case, my dear students, from this end of the chain, the double bond is present between second and third carbon, while from this end, the double bond is very far away. So the correct numbering will be from this side, 1, 2, 3, 5, and 6. In case of this, again, it is the double bond is at terminal, so we will start numbering from this side of the chain. In case of this triple bond, 1, 2, 3, 4, 5, 6. And again, this is a diene having triple bonds at the equal distance. You can start numbering from any side of the chain. So we have given numbers to all the carbon atoms which are the part of the parent chain in all the given examples. The next one is the naming the alkene or alkyne, and for naming, first of all, we will name the substituents, and before writing the name of the substituent, we will mention the location of the substituent by writing down the number of the carbon atom to which substituent is attached. In this case, my dear students, in the first example, the location of this substituent is 3, so you will write down 3. Now it's basically a propyl. It is a normal propyl. So you can write down normal propyl or just propyl, because if you will not use the prefix normal, it will be understood that this is the normal propyl. So it should be 3 propyl. Now locate the double bond by using the number of the first carbon atom of the double bond. The first carbon is the second one. So 3 propyl 2, that is the location of the double bond. And how many carbons are there in the parent chain? 6. So that will be hexene. It will be 3 propyl 2 hexene, or IUPAC says that you can also write it as 3 propyl hex 2ene. Both are the correct representations of this name. Now let us move to this example. It has some substituents and there are 3 methyl groups. One is at second carbon and 2 at fifth carbon. So you will write it as 2, 5, 5. If the same substituents are present on one carbon, then the number of that carbon will be written twice. 2, 5, 5. There are 3 methyls, so you will write down trimethyl, as there are 3 methyl groups in it. Then you will mention the location of the double bond by using the lower number, that will be 2. And how many carbons are there in this parent chain? 6, so that will be hexene. So it will be 2, 5, 5 trimethyl 2 hexene. Now let us move to this one. My dear students, at second carbon there is a propyl, but this is not like this propyl. It was normal propyl and this one is the isopropyl. So it will be 2 isopropyl. The location of double bond will be, it is between first and second carbon. You will use the lower number 1, and there are 5 carbon in the parent chain. So that will be pentene. 2 isopropyl, 1 pentene. And my dear students, now let us name this diene. It is basically alkadiene. It has 2 carbon-carbon double bonds. Now there is no substituent here, so you will mention the location of the double bond first using the lower numbers of the carbons. It is between first and second carbon, so you will use the lower number 1. Third and fourth carbon, 3. There are 4 carbon atoms, so that will be butadiene. Because those alkenes that have 2 carbon-carbon double bonds, they are called as alkadienes. And those with 3 carbon atoms will be called as alkatrienes and so on. So it is a butadiene, it is an alkadiene actually. Now let us write down the names of alkynes. My dear students, there is a substituent on 5th carbon. So you will say 5 methyl, and the location of triple bond using the lower number, that will be 1. There are 6 carbon atoms, so it will be hexyne. 5 methyl, 1 hexyne. Now this one is an alkadiene basically. It is an alkadiene which has 2 carbon-carbon triple bonds. There is no substituent, so first of all mention the location of the triple bonds, that will be 1 and 5. And there are 6 carbon atoms, so hexadiene. That will be the name of this diene. My dear students, these were the examples in which we named some alkenes and alkynes. Now there is a example, in fact there are 2 examples in which you have both carbon-carbon double bonds and carbon-carbon triple bonds. The carbon-carbon double bond is represented with ene, and the carbon-carbon triple bond is represented with ine. Now, while the compounds that have both carbon-carbon double and carbon-carbon triple bonds, they will be called as enines. So all those aliphatic hydrocarbons in which the carbon-carbon double bond and carbon-carbon triple bond both are present, they are called as enines basically. This one is an enine and this one is also an enine. Now the rules are again same, selection of the parent chain. In case of numbering, very important, listen very carefully. If the double and triple bond are at equal distance, just like in this example, you can see from this end the double bond is present between first and second carbon, and from this end the triple bond is present between first and second carbon. Then which one of the following will be preferred? Either you will prefer the double bond in numbering or you will prefer the triple bond in numbering, because we name them as enines. It means we first write down En, which is an indication of the double bond, and then we will write Yne, which is an indication of the triple bond. So while naming them, En is preferred. It means that when you will be numbering the parent chain, then you will start from that end where the double bond is nearer only if the double and triple bond are at equal distance. But if they are not at equal distance, then you will start numbering from that end from where the double or triple, any of these, that will be nearer. In this case, this one will be first carbon, second carbon, third carbon, fourth carbon, and fifth carbon. Now, look at this example again. The straight chain will be the parent chain. Now, the triple and double bond, they are not at equal distance from both ends of the chain. The triple bond is between first and second carbon, but the double bond is present between third and fourth carbon. In this case, you will not prefer the numbering from the side where the double bond is nearer, because that is the option only when the double and triple bond both are at equal distance from each other. So in this case, you will start the numbering from that end where you will find triple bond nearer. 1, 2, 3, 4, 5. Now, my dear students, after selection of the parent chain and after numbering the carbon, now, while naming these enines, first of all, you will forget the triple bond. You will consider as there is no triple bond in the molecule. There is only double bond. If there is no triple bond in the molecule, then what should be its name? Its name should be 3-methyl. 3-methyl 1-pentene. For getting the triple bond, its name should be 3-methyl 1-pentene. Now, you will suddenly call in your mind that the triple bond is also there. Then you will remove this E. You will mention the location of the triple bond by using the lower number, that is 4. And then you will use the suffix for the triple bond, that is ine. So its name will be 3-methyl 1-pentene 4-ine. While naming the enines, it will become very easy for you if you will first forget the triple bond and you will name the compound just according to as it is an alkene. And after completing the name, considering it as an alkene, then you will write down the location of the triple bond and use the suffix YNE. In this case, there is no substituent. So first of all, mention the location of the double bond. Forget about the triple bond. It is 3 and there are 5 carbons, so it should be pentene. It is 3-pentene. Now, naming the triple bond, for naming triple bond, you will remove this E. It will be 1-ine. So 3-pentene 1-ine, that will be its correct name. I have given the examples of alkenes, alkadienes, alkynes, alkadienes, and enines. So this was a lecture full of concepts and full of learning. Now you will practice some more naming at your home, and if you will find any problem while naming the alkenes or alkynes or enines, you can ask me in the comment section. I will definitely be there to help you out. Till then, take care.